Okay, last section of chapter 6, energy use in the environment. I'm not going to test you on this stuff, but I think it's helpful to look at because it ties what we just learned about all this enthalpy and stuff into practical matters. So, according to some statistics in the United States, each person uses over 100,000 kilowatt hours of energy per year. If you remember that table of energy units, a kilowatt hour is a lot bigger than joules and calories. Most of that energy comes from the combustion of fossil fuels. The problem with fossil fuels is, they're not renewable, and when they're gone, they're gone. But these combustible materials originated from ancient life. And we can calculate how much heat is released. One way we can evaluate the fuels is to determine how much they release relative to how much CO2 they produce. And so when we say this fuel is a better fuel or it's better for the environment, what we mean is that it produces more energy for the amount of carbon dioxide that it generates. Some fuels generate more carbon dioxide with less energy. And so better fuels are going to have higher ratios of heat to carbon dioxide production. We can't make more fossil fuels. And anytime you see statistics like this, these are not hard and fast numbers. These are based on assumptions and estimations, and they're helpful, but they should not be taken as gospel fact. At current rates of consumption, oil and natural gas supplies will be depleted in 50 to 100 years. And this is showing where those types of fuels are being used. This shows energy consumption by source over the years from 1950 up to 2010. And we can see that renewable energy has had a small increase. That would include wind generators, generators from wind and solar panels and hydroelectric plants. We got nuclear electric power. There was really not much of that at all before 1970, and that's gone up. There's issues with that. Here's coal. The use of coal has gone up, and then it's kind of gone down a little bit. The problem with coal is it produces a lot of pollutants. We've got lots of coal, but it does not burn very cleanly. Natural gas and then petroleum products are definitely our favorites, and this is what you make gasoline for your car out of. All these combustion products have an effect on the environment. And it's not just the carbon dioxide. And we've learned that hydrocarbons burn to form carbon dioxide in water. You might say, well, yeah, we don't want too much carbon dioxide, but hey, that's pretty good, that's pretty clean. The problem is these fuels that we're burning are not pure hydrocarbons. They contain other things. Could we make them into pure hydrocarbons? Yes, but that's not going to be economically feasible. So there's additives. For a long time, they put tetraethyl lead in gasoline, and then they realized, oh wait, that was a really bad idea because now the whole country is contaminated with lead. That was an additive that was not a good idea. There are also impurities. You can end up with incomplete combustion. If you've got gas appliances, you want to make sure that they get enough oxygen. We had a close call at a cabin in northern Minnesota when the gas refrigerator, because we didn't have electricity out there, the gas refrigerator, one of its little vents that we didn't even know it had a vent there, was clogged up, and so it was pumping carbon monoxide into the cabin. Thankfully, the cabin is very porous, but it was a very still night that night, no air moved, and so, yeah, I'll tell you that if you want the rest of the story, I'll tell that off YouTube. But carbon monoxide is a product of incomplete combustion. So in your house, it's very dangerous. People die every year of carbon monoxide poisoning, and it's tragic. But incomplete combustion can also happen in your car. And so that generates pollutants. There can be side reactions. Bottom line is harmful materials get released into the atmosphere when fossil fuels are burned for energy. So these fossil fuel emissions are contributing to air pollution, acid rain, global warming. The Clean Air Act has helped. We're seeing a change in pollutant levels from 1980 to 2010. We've seen a drop in these pollutant levels, so progress is being made, but still room for more. Global climate change. My personal belief on this is that I don't think anybody has really proved anything yet. And so I take anything I hear about this with a grain of salt. I'm not in a big panic about a 0.7 degree change in average global air temperature in the past 100 years. There are a lot of factors. Now, this is something that needs to be studied, and we need to be concerned about it, but we don't need to freak out about it. CO2 is a greenhouse gas. If we had no carbon dioxide in our atmosphere, our planet would be very, very cold, and there would be no life. So we need carbon dioxide in the atmosphere. It acts like the glass lid on a greenhouse. The energy from the sun comes in, and then the carbon dioxide keeps it in. But we don't want too much either. And so, yeah, it's this balancing act. But then we're also not exactly sure, is all the carbon dioxide our fault? Or is some of it natural? Is this a natural fluctuation that global temperatures are going through? It's really a big puzzle. Atmospheric carbon dioxide has gone up since 1860. Most definitely. Renewable energy is definitely something that needs to be looked into. Here in the Central Valley, solar energy works really well. Solar panels, we've got sun so much of the year. Solar panels are awesome, but there's a lot of different options for renewable energy. And these are areas of active scientific research because it needs to be efficient and practical. So those are neat fields to get into. Pictures. End. Yay!